nice, man. I like them. Plus they're Pondo colors, so I can wear it as my Pondo shirt. Yeah. All right. Happy Friday. Good to see you. Just wanted to put this up for next week, especially Monday, so you know what's going to happen. I'll just kind of express what I've heard from the Suco sponsors, that it's not so much about raising as much money as possible, but participating as much as possible. Okay, that's going to be the thing that I think we're going to hopefully kind of bring us together a little bit. Wish Week is by far my favorite week of the year here at Ponderosa, because I feel like every year we get to this point in the year and we're kind of drained, kind of worn out a little bit, and it kind of brings us back together to do something for somebody else, especially somebody that is in a much tougher spot than most of us. So
also pool/beach gear. I don't know how that's.
I agree. I think we're going to be, there's going to be a few people that make their way to the office on Tuesday for a poncho or something to cover themselves up. So choose wisely for sure on these days.
100%.
It's going to be interesting, especially if it's like being nice out there. So Monday's class colors: freshman yellow, sophomores blue, juniors green, seniors are red.
The other way around. Yeah, that's messed up.
That's backwards.
Seniors are green, juniors are red.
So switch these.
Yeah, they messed up.
Okay, so switch those. If you're a junior, wear red. If you're a senior, wear green. Okay. If you are thinking about going to the movie, you have to sign up for it on My School Bucks. Okay, because there's limited seating there. They're showing Raya and the Last Dragon, the new Disney movie, which is actually Zoe's sister's name, which is awesome. And then Chipotle and Castle Rock. And so we'll just leave it at that for today. Okay. But there it is. I will put this on Canvas so that if you want to kind of plan ahead for what you want to be able to do and when, and just make sure that if you do go to any of the Dish for the Wish, that you let them know that you are with Zoe for Wish Week, so that they can kind of mark off, like they put your receipt in different piles so that they can kind of calculate how much collectively we purchased on that day, and then give some of that back, which is awesome. Okay, dodgeball on Tuesday, Deca barbecue on Wednesday, talent show on Thursday, and I think, yeah, parade on Friday, which is nice. If you haven't got your Wish Week T-shirts, definitely get those ordered. I believe that's My School Bucks as well. And that's it. What I wanted to do today is give us a chance to practice product rule stuff. Okay. And so I put up a homework assignment on Canvas that you can start today, and if you need some more time, you can finish it this weekend. It's finishing what we started yesterday, page 138, including the one at the bottom. Everything on page 186, and then 7 through 9 on 187. I think you might be able to get it done today. And if you can't, any time before Sunday at midnight, just finish those up. But I wanted to point out a couple things. I don't know why it does this, but look closely at what they're asking you to do on certain questions. Okay, the one on the bottom, page 183, find the equation of the tangent line at a given t-value, that 5 or 6. Okay, so you'll actually go through the process, find the derivative. But that's just the beginning. Right? You have to plug in pi over 6 into the function to get the y value, and you got to plug the pi over 6 into the derivative to get your m for the slope. Okay. And then skip. I don't know if I made copies of page 183 and 184 or 185 or 183, 184, 185. Yep. I don't know. I tried to leave out some of the things that maybe we weren't going to do, but I probably put them in there. But then on page, I think it's 186, yeah, it's the start of what it says day 19 homework. But look at the difference between question 1 and question 2. Find the derivative by rewriting it first, and then apply the power rule. Find the derivative by applying the product rule. The idea here, like I said a couple days ago, or even just yesterday, sometimes they're going to ask us to do the same thing 2 different ways and make sure that we can get to the same spot. Okay? So first one says rewrite it, right? Rewrite the function, do the work ahead of time. Second one says use the product rule and kind of do the work back end. And then look, it says for number 3 through 5, That should probably be 3 through 6. Find the derivative. It doesn't say how, so use whichever version you want. Okay? Whatever you think is going to be easiest for you. Okay? So look closely at the instructions, because then you get to page 187. 7 and 8 say find the slope of the normal line, not the tangent line, but the normal line at those indicated values. Quick recap. Do you guys remember how the normal line and the tangent line relate to each other? We talked about it briefly. I want to bring it back. They're perpendicular. Okay, so you'll find the slope, right? Plug in pi into the derivative, and then opposite reciprocal will be a slope of the normal line, right? So just kind of pushing the boundaries a little bit, giving you a chance to see what you can do. So normal line and tangent lines are perpendicular, so flip your fraction and change the sign. That'll be 7 and 8. And then 9, find the equation of the tangent line at a certain x. Okay. I'm okay if either your slope or your y value, because they're giving us the x, so we know what that is, if they're irrational, to just round to 3 decimal places. Okay, you do not have to find the exact value of your y's or your slopes at a given x value. I'm good if you round to 3 decimal places, so you can just drop in your calculator and see what it is. If you want to find the exact value, even better. But don't worry about the bottom half of page 187 here. Okay, so just 7, 8, and 9 there. But all of page 186, and just finish up whatever we didn't on page 183. You have all of class to just get that practice started. Okay, I'm going to keep going. I'll keep kind of putting work up so that you can feel pretty good about it. And if something comes up and you have questions, great. But the time is yours to work. We're out of here at 10:25, I think. 9:45 to 10:25. So you might need some time this weekend to finish it up. But that'll give us a chance Monday to start the second of the kind of the big 3 rules on the pages that come on. So if there's something that you want to see, let me know. I think I might have said this yesterday. I forget if it was our class or fourth, but when you look at the bottom left one, this g of theta, and you're looking for g prime, right? It's the derivative of 3 theta is 3, plus there's going to be my product rule right there. Your u is theta. This one right there, your v is sine. That one. So within the function, I've got a product that's just part of it. Okay, so u dv plus v du, and that's what. Let me know what you want to see if you want to check things out. Simplify as far as you can. I don't know how h of x is going to work out there, because we've got sine of x, cosine x, and the derivatives are pretty closely related. So we might be able to simplify a little further. We'll see how that plays out. It might be some Pythagorean, I think. Try to use it. But give it a shot. Let me know if you want to see anything worked out. Maybe I'll do that. All right, so time is yours. Talk to each other, talk to me, talk to yourself, whatever works for you. One of these days, Colin, you're going to bring me one. It's just going to make my day.
Never told me that.
One day. There probably isn't coffee that I would. Let's get some work up for you. So your u equals and v equals, I think, is going to help. Okay, if you want to do that prep work ahead of time, I think that's going to help you. And then your du's and your dv's. We did this one, right? That one, this one. Probably lots we can do with that last one in terms of simplifying, right? In terms of just sine or just cosine. But that's good. It's not exactly one, right? It would have to be sine squared plus cosine squared. This is negative sine squared. But you can use a version of sine squared plus cosine squared equals 1 to write it in terms of just one single trig function rather than two. So I think you've got some choices here. That's one version. Let's see. So cosine is 1 minus sine, so maybe like 1 minus 2 sine squared would work. Sine squared is 1 cosine minus 1, 2 cosine squared minus 1. Any of those three versions, I think, for the last one's good. Kind of your choice. Usually these two would be preferable because it's just one trig function rather than. I don't think they specified that we had to. Sometimes they'll say, and write your solutions as a single trig expression, if possible. But here they do. I'm good with any of these. These two over here, or this one. Not sure. Yeah, let me know if you have any questions. I'll keep putting some random ones up. This is the first one. Yeah, I haven't graded the second one yet. This is just the one that I did not. I think that's it. No, second half stuff I'll grade this weekend and get that back to you hopefully Monday. All right. I'm going to do the last one here on page 183, just because it gets us to go a little further by finding the whole equation. So the variable of differentiation here is definitely going to be t rather than x. So really, this is du dt. This is dv dt. Ah. For hey, you know what? Let's see the other notation. Just use it. dy dt. U plus v u yeah, that squared over 36 times. Which is, I don't know. What is that? Squared root 3. You can see why we round. My goodness. Root 3 over 72, right? 6 times 12. 770. Now, all of the like actually evaluating, you don't have to do that. You don't have to find the exact right answer. That's a situation where I go into my calculator, I type in the function, I type in the derivative, jump into the table and type 5 or 6. I'm just going to see what decimals I get back. Let's make sure I did it right. Let's see. All right, so our original x squared, I guess, cosine of x. Bless you. Negative x squared minus plus 2x cosine of x. in radians, go to the table, delete some old stuff, type in pi over 6, and cross your fingers. 0.237, 0.770. Nice, I did it. Anything boxed in green there is extra. Okay, you can jump right to the approximations if you use your guess. Yeah, so 183, 186, and then just the first 3 on 187. We've got like 15 more minutes, so put as much of a dent in it as you can, and then finish things up this way. Maybe like 5 more minutes, I'll leave that one up. Another one. I think 186 is relatively straightforward with just mostly just here find the derivative. And I think there's some overlap a little bit in the questions. Actually, let's take a look at that real quick. I think there's, yeah. So the sine of x, cosine of x1 on 183. There's a sine of x, cosine of x1 as well on 186. Don't do that twice. Okay. Unless you want to challenge yourself again. So should you do it on different days? But the last one within the boxes on page 183 is the last one within the boxes on page 186. That sine of x, cosine of x. Don't feel like you have to do that one twice. But what you see when you get onto 187 is at number 8, same function, but they say, okay, find the slope of the normal line at that spot. You've already done the derivative, so feel free to use it right away. All right, so if you recognize you've already done the derivative, don't feel like you have to do it. Bash my hand on the desk, like right in that like weird like nerve spot right there. It's hard to train. Give another moment or two with this one up, and then I will. Again, normal line is perpendicular to tangent line, so keep that in mind when you get to those kind of questions. Use your calculator often. Wow, we'll do that. All right, I'm moving on. If anybody needs me to pause, let me know. That's a good one. Let's see what a good one do like. Skipping. I'll do the top 2 here, maybe. Then we multiply, we add the exponents, that's 7 letters. There's 1 and 2 on 186, I think. Find the derivative. Two different ways of getting the same. Same function, same derivative, no matter how you find it. Looks like 1 is easier to do than 2. It usually is. Right? If you can multiply it out, okay, usually going to save you a little bit of time. And when you multiply x's, you add their x's. Got about 10 minutes. So get at least one more done if you can. And ask questions now. Definitely want to talk product rule now, because Monday is quotient rule, and we're going to get right to it. Find the slope of the normal line at a certain x value. So you want to find the derivative first. You can plug it in to get the slope of the tangents. Then we'll just do opposite reciprocal, and that'll be the slope of your normal. Calculus A, what are we going to do first? Find the derivative. There's no way to get to the normal line right away. We have to find the tangent slope first, and then we can just make a switch. Let me do those. Let me get you started on the last of 3 pages. This one's just find the derivatives, find the derivative, find the derivative. Slope of the normal line. 197. Come back to that. All right. Plus, this is interesting, sine of x over 2. And v prime of I prime cosine of pi 0 over 2 negative negative prime, which implies normal line 1 over root. This is kind of a good way to wrap that up at the end. The slope of my tangent line is this, which implies that the slope of my normal line is that. Now, to do those right, you've got to get the right answer. Right? We have to evaluate those directly, which I think is why they picked pi and not like pi over 3 to make that kind of nasty. The relatively easy exact value to find that negative root pi compared to a lot of other choices within the unit circle, which is, I think, why they went with the quadrantal angle, so that's something to disappear on. And again, for 8, we already did that derivative. Right? We already know that h prime of x, I believe, was negative sine squared plus cosine squared, or whatever version you decided to go with. I'll just stick with that one because that was kind of the original. So I can plug that in right away. I will 4a. All right, so negative sine squared 4. And remember, sine squared and cosine squared, we find the sine, see what you get, and then square it. Right, don't change pi over 4 into pi squared over 16. What this really means is negative sine of pi over 4 squared. Like, that's what that means. I'm not going to write that, but I'm not going to keep that, but that's how. So negative 2 over 2 squared plus 2 over 2. So it is negative something plus positive something 0. So the slope of my tangent line is 0. That implies the slope of my normal line is this is going to be a vertical line. It's continuous there, but the derivative is not. That's going to happen. I'm going to take a look at the actual function just for a second. I want to take a little peek here. Sine of x, cosine of x. I'm going to like y equals. I'm going to do this. Pi over 4. There it is. Kind of hard to see. Let me see if I can see it. Right. There we go. Perfect. Right. Pi over 4 is the relative extrema, so the slope of the tangent line is 0. So the slope of the normal line is perpendicular to that, which would be right. Questions at home, anybody? How we doing? Is this going okay? This should be enough practice for us to feel pretty good about it. So, I'm not going to get any crazier than this. No need for that.